A test for the difference between matched pairs is usually called a paired t-test. Test the difference between paired observations, such as the difference between cholesterol levels for people before and after treatment, or you doing a task with your left hand and then your right hand. We can't mix somebody else's left hand with your right hand. We must have a reason to pair the observations to use this test. Here we have 15 ball bearings that we can test for hardness using two different methods. We want to see if the two different methods provide the same information. Each bearing is tested both ways, and we want to see if the two methods produce the same result. The usual hypotheses are that the difference is 0 versus the difference is not equal to 0. This is the data for the hardness test for the two bearings. Excel will do the paired t-test, or it can be done with the mean and standard deviation of the differences using the usual test procedures. Either way will do. To use Excel, choose the Data tab and the Data Analysis Toolpack. Scroll down to T-Test Paired to Sample for Means. Click OK. The variable data for range 1 is here. The data for 2 is here. And again, we have the choice of a alpha level. We'll leave it at 0.5, and we have a place to put it. Where do we want our output range? And we'll just put it in this place right here. Click OK. And here are the results of the test. I'll open it up a little bit. They always crimp these things in. The test statistic is 2.81. The p-values and the critical values are like those for the two-tailed test, so that we need the p for two-tailed, we need the p for two-tailed, and the t critical value for two-tailed. 2.81 is greater than 2.14, so we reject the null hypothesis. We can also do this with a regular test. Calculate the mean difference, which is 8, and the standard deviation. The sample size is 15, so that the standard error of the mean difference is 11.025 divided by the square root of 15, or 2.846. If we do the usual test of the hypothesis size difference subtracted from the mean, we have 8 minus 0 divided by the standard deviation of the difference, and we get 2.810, the same t statistic in both cases. We can compare it to 2.14. Again, it's still outside. It's a two-tailed test, so our p-value is double the single-tailed p-value.